a Sunday bar has 12 different toppings. How many sundaes can be made if there is no limit to the number of toppings you can choose? Now, the long way you could do this is calculate the number of, you could use 12 choose 0 to figure out the number of sundaes you could have with no toppings, plus 12 choose 1, which is the number of ways you could have one topping, plus 12 choose 2, and so on, right up to 12 choose 12. And what hopefully you recognized is that that is going to be a complete row of Pascal's triangle. And so the sum of the 12th row of Pascal's triangle is going to be 2 to the power of 12, which is 4096. And again, if you add up 12 choose 0 plus 12 choose 1 plus 12 choose 2 right up to 12 choose 12, you end up with 4096 as well. Now the next question, if basketball team carries 14 players, 3 first-year players, 5 second-year, and 6 experienced third-year players, how many ways can the coach choose a starting lineup of 5 with at least 1 first-year player? Now, some of you may say that this is a combination, and some of you may say it's a permutation, and I can see the argument of both. So to me, I wish I'd have reworded this question because it seems a little bit vague. But if you say that there is a center, a left forward, right forward, point guard, shooting guard, etc., then you're identifying that these positions are unique. So this would be a permutation. And if you took it to be that you're just picking 5 people to start and you're not really worried about the position they play, then you could use a combination, and I would accept both answers. Now, for the first one, the number of ways that you could, the number of starting lineups, well, we can use an indirect method because we call that, if we're going to look for at least one, we could have, figure out the number of ways we could pick 1 first year, 2 first year, 3 first year, right up to, well, actually 3 because we've only got 3. Or what we can do is figure out the number of starting lineups possible minus the number of ways we could have 0 first year. So if you use permutations, then it's going to be the permutation of 14 choose 5 minus, the number of ways we could choose 0 first year will be permutation of 3 choose 0, so we're not choosing any of the first year players, times the number of ways that we could pick a starting 5 starters out of the 11 second and third year players. And this is 240,000, 240 minus, and that'll be 1 times 55,440, which is equal to 184,800. Now, if you had to use combinations, you would have gotten an answer of 1540, and that's in the written solution that I've provided for you. That is, I've done it using combinations. And so either one I would have accepted for full marks on this assignment. Now the next question, in how many ways can the coach have a starting lineup of 5 with 2 second year and 3 third year players, or 3 second year and 2 third year players? Now, this will be the rule of sum because we're going to have to figure out the number of ways we could have 2 second year and 3 third year, and then add that to the number of ways we could have 3 second year and 2 third year players. So if we're going to use permutations, it's to pick 2 of the 5 second year players will be the permutation of 5 choose 3, 5 choose 2, and we're going to pick of our 6 third year players, we're going to take 3 to be the starting lineup. And we're going to add then the permutation of 5 choose 3, which would be the number of ways that we could pick 3 of the 5 second years to start the game, times the permutation of 6 choose 2 is the number of ways that we could pick 2 first years out of the 6, 2 third years out of the 6 to start the game. Now, The permutation of 5 choose 2 is 20 times 120 plus 60 times 30, and this is equal to 4,200. Now, if you used combinations, you would have used a combination of 5 choose 2 times the combination of 6 choose 3 plus the combination of 5 choose 3 times the combination of 6 choose 2, and you would have gotten an answer of 350.